In our standard tool crib, the 8x40s, we have an ingress and an egress door. So the ingress door typically is where your workforce will come through. What they'll do is they'll step up to the cabinet and ask the person who's manning the tool crib to get the tool for them. And then as they get their tool, they're able to walk out this door and not be impeded by somebody standing on the outside of the door and walk through. So typically in a blast environment, they'll only allow about 3 people inside of this booth here inside as they're coming through to get tools. So you have one picking a tool up as you're having one leave the building. So, and then with the cabinetry here, what you'll see is the sides here. When you look at it, I'm going to go ahead and put this down for a second. But what you'll see inside of our standard tool cribs is a communication port on the one side here where your phone lines and your computer lines can be hooked up. They're hooked up through the rear of the tool crib, and then lines run all the way to the front. We've got an additional light above the work surface here. Then we also have multiple electrical outlets for whether they're cleaning oxygen masks or whatever they're cleaning here, they can clean it. Also, we have an air inlet and outlet set up so that they can use air inside of here for air tools or anything else. What you have on the other side is what we call our chain fall or our gasket rack. You can also hang air masks or whatever you need to hang. Anything that needs to be hung can be hung on these pegs here. They use them for all types of things. As we go further back inside of the tool crib, you come to another area which also has been configured to where you can lay chains over it, air hoses over it, whatever you need to lay over it, or these pieces can be removed and shelving can be inserted in the area. Then when you're looking at the tool crib, API mandates that anything above 42 inches has to be behind a closed and latched door. So what we have is we have an open environment down below, because in a blast, anything that was to come out of the cabinetry is going to hit you below the waist, and it's not going to be damaging to your torso or your head. So when you look at our cabinetry, all of our cabinets on the inside have locking latches on them, and they are also set up. They are also set up to receive padlocks if there are sensitive materials on the inside. But as you walk down, each cabinet section is a 5-foot section. So in a special need, if we needed to have all cabinetry with no shelves in front, we would just remove all the cabinet space or all the counter space up front and add more cabinetry to it. Same way on this side, we could actually add more cabinetry if we had to in the 5-foot sections. This booth here, or this tool crib, is actually a 8 psi, 200 millisecond medium response booth. The reason for that is that all the reinforcements that we do inside of the walls, with the addition of the tool crib cabinetry on the inside being metal, it reinforces the wall that much more so that it doesn't bend in or move on you. And then we also have along the floor, we also have reinforcements along the floor to help keep cabinetries from moving in a blast. When you're looking at all of our lighting on the inside, we use a correctional facility light fixture, which is something you would see inside of any penitentiary. It's tamper-proof, but on the inside of it, there are also fluorescents. Those fluorescents are also covered with a coating, or basically it's just a vinyl wrap around them. So if they were to explode inside of there, they're still going to be self-contained inside of this shield, but if the shield came off, they're still not going to fall on the occupants on the inside. The other thing to note when you're walking through any of these tool cribs is that all the electrical is exposed. The reason for the exposing of all of our electrical connections is that in a blast, some of the electrical stuff is going to come off the walls. When it comes off the walls, we want to be sure that you can see if there's any broken electrical connections anywhere inside of the module. If there is, you know immediately that you do not want to power the module up. As you come through the back of our module, or the back of the tool crib, what you'll find is all your tool crib cabinetry till we get to the back. All tool cribs have dual PTACs in them, or HVACs, air conditioning systems. Standard would be an 18,000 BTU at the rear of the module. Then at the front of the module, we have an 11,000 BTU up at the front. Just keeps the environment cool, or in the winter, it keeps it warm. What we'll do now is cover a little bit about a blast building and what it is, the philosophy behind it. So blast buildings are BRMs when you look at a box for you, or there are blast trailers or blast modules. Anyway, what a blast module is it's designed to take a blast in a refinery environment. So if there's an explosion, or in an open field if it was used in a defensive arrangement for the U.S. military. But what happens is in a blast, you have a lot of energy that comes across to a blast wave, hits the outside of the box, creates energy on the inside. So what we do when we design our boxes is we look at the interior of our box and we think of it like a human rib cage. So when you're looking at the walls, what you're going to see is you're going to see screws every 22 inches. But basically every 11 inches behind this wall is a steel reinforcement, so it's not a standard building. But the reason for that is the rib cage dissipates the energy. If you were to think of a boxer, when he's in the boxing rink, if you've ever watched it, and watched another boxer hit him in the ribs in slow motion, the ribs move in and move with the blast of the fist, and then as the fist comes back out, the ribs come back, and all of that energy or that blast is dissipated through his rib cage and his structure. So that's what we do with the blast module. We absorb all of the blast that hits on the outside through all of our members and dissipate the energy throughout the entire building. So what happens is it creates a safe environment in here. If you were standing in here and we had a 5 psi blast on the exterior of it, you're going to have a little bit of hearing damage just from the blast because it's going to be extremely loud. But as far as damage to your body, you may have maybe broken fingers, maybe some broken toes, maybe a broken arm if you fell, but you'll still have your life.